I'm Dave Aronchick. I am co-founder of Expanso, the distributed compute company, and the open source project Bacalhau. For those that haven't heard, Bacalhau is effectively like a global version of Kubernetes. Not a replacement for Kubernetes, just kind of missing the components that Kubernetes isn't good at, right? Not a replacement, just different. It allows you to run your jobs where your data and users and so on are. One scenario that we see a lot of people using this for is around machine learning, where sure, your enormous foundation model runs great in an awesome data center with 8 GPUs or whatever, 16 or 400 GPUs. That's great, but it turns out that much of the value of ML will not occur on those first, 10 or 100 machines, but on the next trillion machines that are spread all over the world. So, those that were at the last talk, there's a little bit of repetitive, but this is in fact a different talk. So it starts with this, right? Data is exploding. Again, not terribly interesting new stuff here. We all know that data is growing incredibly fast. I don't even know what a zettabyte is. I can never keep track of it, but it's a lot. And IDC says that this year we're going to generate 175 zettabytes. That's interesting, of course. Big number, very, very cool. But what's more interesting is that where that data is being created is not in your central data center by and large. It is being created all over the world. 60% of it is estimated to be created outside of core data centers. What am I talking about? I'm talking about things in branch offices. I'm talking about things in retail stores. I'm talking about this particular laptop right here that is generating data. Video, imagery, satellites, planes, trains, automobiles, you name it. Data is being created everywhere. And by and large, people can't keep up. Now, one of the reasons they can't keep up is because there's this attitude about the way to approach data which is unfortunately not adapted for the way the world looks. And that is exclusively centralizing your data, right? Who here has a pattern where your first job is to take the data from wherever it is and ship it to an S3 or S3 compatible bucket sitting inside a single data center in whatever, Iowa, right? Pretty standard. It's not bad. We understand and we do it because it's the cloud and there's infinite compute and there's infinite storage and, great. The problem is that this has many challenges. One, it is slow and costly. I like to joke that in 10,000 years' time, the ping time between New York and LA, or whatever remains between New York and LA, will still be 49 milliseconds because the speed of light is not getting any faster, right? So if you have anything that requires awareness in under 49 milliseconds, you're going to have to come up with another solution. And so when it comes to moving data, particularly in that case, you're going to run into a lot of challenges. And it could be 1 byte or it could be 100 gigabytes. The same problem applies. But then you go beyond that, now we're getting to a point where things are not free, right? Again, we think about the cloud being infinite and so on and so forth, but lots of people are looking at their cloud bill and saying, holy crap, this ingress-egress thing, where did this come out of? What's going on here? So just moving that data is no longer free, let alone storing it. Second, security. I bring this up all the time. People moving raw data, like that was basically the core of the log4j, issue, right? That was people taking their raw log lines, sticking it into their central data center, and then running processing on it. Like, talk about security nightmare. Shouldn't you do a little bit of processing before you move it so that you're intelligently moving just what you need and making sure you're not opening up a brand new hole for attackers. And then finally, even if neither of those were the case, regulations are growing, right? Most people don't realize, but if you move an IP address with the last octet intact, you are violating GDPR, okay? So and I can guarantee that most people do this. Now, it doesn't require much. It's just a single command to remove it and make it 0, and it doesn't hurt your awareness or analytics or anything like that, but nobody is doing that, and that's what GDPR says. And those regulations are only growing. So, even though I'm talking about things like data lakes, it really applies everywhere. Centralized, multiple data centers, multiple clouds, remote data centers, edge devices. We're just not thinking about this in a holistic way. And by that, what I mean is this. All those things on the right-hand side, they're great. Don't change them at all. They're wonderful, use them. They do great job once the data is there. But everyone thinks about their data process as starting where the arrow begins or ends. You have to think about the left-hand side, right? Multi-cloud, multi-data center, edge, IoT, on-prem, that company you just bought last week. Like, that's part of your data network as well. And if you're like, well, don't worry, I'll deal with it when it gets to the central data center, you're just writing yourself debt. You're writing yourself money debt, you're writing yourself security debt, you're writing yourself dev debt, you're slowing your innovation. You need to think about this in a more holistic way. A very real scenario that we're dealing with right now, we have a proof of concept working with a city who is generating, they have about 15,000 cameras spread around their city. Every one of those, it's actually hard to get like a non-4K camera today. A 4K camera is like the low end. And when you calculate, if they were to move all that raw data into their central data center, you're talking about 4.4 petabits a day, right? It would bankrupt the city overnight. What they do instead is this, right? They put a human being nearby those things. They watch those on a monitor. I had something in here where I passed by in this particular city, and it was like, one of those giant OLED things, and a single human being sitting in front of it, and the squares were about that big, and they had 100 of them. I'm like, there's no way this person can derive value of this. And then they throw it out. After whatever, a day or a week, it's just gone. And that's just because that's the way it works. That's the only way they can avoid bankruptcy. So my proposal is that an exclusively centralized architecture will never get at everything that you need. It won't give you a global processing pipeline. It won't let you support the way the internet was built. Again, the internet was built for unreliable networks. And if you have a network that requires constant connectivity, you are doing it wrong. You will run into problems. And then we haven't even gotten into autonomous systems and drones and all the devices in this room. You need a system that treats all that data architecture like one thing. This is where we come in. So like I said, we are a company called Expanso. We provide an open source platform called Bacalhau. It is designed to be a globally resilient orchestrator that enables you to have a much more flexible solution for managing your data pipelines. We help you be reliable. We help you be secure. We help you build resilient infrastructure. So if things join and leave and so on and so forth, we handle that as well. And we do this for what I like to say is the next trillion servers and devices. What do you get out of this? Well, because you're now treating your data pipeline in this way, in this flexible way, you get things much faster. You can take action where you are able to detect something. If something is throwing an error or something like that, you can do automated remediation and so on. You also, by the way, make your back end much faster, right? We all forget about this, but you're like, wait, why did this query, this simple query, take so long? Well, it turns out you were running over 100 million rows. And those 100 million rows were not really what you wanted. It would have been much nicer if those had been aggregated into a view that was much more flexible. You can do all of that. You can make your overall pipeline better simply by looking at this in a more holistic way. Also, by the way, we make it much cheaper. If you go and look at your compute jobs, the cost of running in those central data centers, you will find that it is very expensive because they know they can charge, because you've now moved all your data into that location. I'm not saying don't continue to use that. That's great. Keep using them, but just use less of it. Use the compute you've already paid for. Those devices, those Raspberry Pis and those VMs and multi-cloud and so on and so forth, they can do a lot of stuff. A lot more than you're probably doing with them right now. And we can help you do that. Leverage unused hardware. And then finally, more secure, right? I already talked about how we help you filter, help you aggregate. We also help you provide lineage and provenance and governance at the point of data creation, right, before you move it. And one thing I like to stress here is that even though I've talked about all these jobs, All these jobs, like we don't require you to adopt a new SDK. We support Docker and WASM and arbitrary binaries. We support the code you already know and love, right? You don't have to go and rewrite your entire system. I like to say if you have a 17-step pipeline, we don't ask you to rewrite steps 1 through 3. We simply help you grab that steps 1 through 3 and move them to where the data is being created, and then continue on with 4 through 17 to your heart's content. What Bacalhau, the open source project, does, and again, backed by Expanso, we run in multiple locations on unmanaged infrastructure. We help you run on low resource devices, and we run in front of the infrastructure you already have. And because your data is smaller and cleaner, and your pipeline is cheaper and more efficient, all of a sudden everything gets better. Make sense? Okay, so thanks, Dave. You know, a lot about data. How does this relate to machine learning? Well, a lot of people think that machine learning is some special case in the world. I would like to posit to you that it is not. It is simply an application that consumes data and produces data and needs data from your central warehouse. And I will show you how. So we're going to start with this little story here where we have our developer. She comes along. She says, you know what? I'm ready to roll. I have this great new model. It's time to roll it out. And our SRE says, you know, thanks very much. And the reason she says this is because if your developers are not thinking about how to roll out your applications across all these many locations, they are going to be in bad times, right? This is, I posted this on Blue Sky and I got some answers, right? Like if you talked about how hard it is to roll out applications, particularly in distributed scenarios, what do you have for me? This was a short list, okay? Or it just doesn't work for no discernible reason, right? Like, and it's because there is this natural thought that like the SREs are a different breed. Like we don't need to worry about them. Like, I'm just going to develop this thing and then they'll figure it out. But that's an anti-pattern. You need to have your developers, this is where DevOps and GitOps and all these things come from, be part of the overall process. And the only way to do that is to not ask your developers to have to adopt a brand new SDK or brand new deployment methodology or anything like that. It's to instead include them in the process. Now, again, I'm making this opposition here. Models are just applications. Do not treat them differently. If you are thinking about anything that comes along and says, oh, you know what, GitOps is dead, MLOps is dead, blah, 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 we have a new world, run for the hills from that vendor. Because it's probably a vendor, because they're probably trying to sell you something, okay? Like, I don't want to badmouth my brethren, but like the moment you start to hear that, you're like running into bad times. And the alternative is like, okay, well, distributed is the problem here, right? Like, once I put everything into a single container and run it on a single machine, that'll solve everything, right? Except it won't, because it's the same problem. Everything that I said there still applies, even if you're on a single machine. I promise you, it does. Now, it applies slightly differently, because now you can have like 17 people log in with an SSH, shell. But it's now more likely than not sitting next to your data lake, which you now have all kinds of new problems, right? Because it's no longer separated. So before moving your data, you got all these problems. And after moving this data, you got all these problems. Again, Blue Sky was an enormous help in generating these things. The reality is that, if you're not thinking about your infrastructure in a holistic way, where you're thinking about, how to do things both in a data center, in a zone, cross-region, you're going to run into problems. And so many people are like, well, I don't need, this is a simple thing. I don't need to run on Kubernetes, or I don't need to run on this. And I will say, more power to you. It's not bad to not do it that way, but you are paying a price. You're going to pay a price today or tomorrow or the next day. Today, it might be, well, the price I'm going to pay is that it's going to be very expensive. Tomorrow, the price may be, it's going to be expensive and hard for me to add additional people to the team. The day after that is, it's going to be expensive, hard to add additional people to the team, and by the way, I might be running afoul of the SEC or whatever, EU, who knows what. Now again, that doesn't mean it's not possible or useful to do it that way. But assuming that there are no costs is going to be a mistake. And that's incredibly important. Think about the cost of doing this. Now, the reason you bring this, the reason I bring all this up, I will get to that in a second. The reason I bring all this up is, in this talk about universal AI is when we think about where ML is going to add the most value, it's in these scenarios. It's in the distributed scenarios where your ML model now goes to where your users are instead of exclusively having to access a single API. So you say, well, I'm very smart. I'm going to get around this. I'm going to use Bash, right? Bash is wonderful. I actually will not speak ill of Bash. It's a fantastic tool. However, in these scenarios, even on a single machine, can you tell me that your model is still running, that your model deployed properly, that like it was a slow connection, not a broken connection, that after you deployed, is it still running? Is it health checking? What if you need to update it? What if you need to do it atomically so that you make sure the previous version started when the old one stopped, so on and so forth. There are just so many challenges in these. And tools like GitOps and MLOps and things like that are wonderful, but they don't answer any of these questions, right? Like, all these things are runtime components, and that's where a orchestration system, if you're in a single zone, Kubernetes, if you're not, I would propose that we offer something that help you do that. And that really is the way to begin to scale machine learning, right? So one thing I like to say is that most people look at this and they say, well, I'm going to take my entire video feed and I'm going to hand it to some foundation model sitting on an API in the cloud. And that will give you great answers. It will also bankrupt you within minutes, okay? And it will bankrupt you like either because, probably from a dollars perspective, but also from a debt perspective, also from a fact that you don't control that perspective, right? And I'm not trying to be a boogeyman about it, right? You have no idea if they're going to change their model like from day to day. You just have no idea. And it's not bad, it's just a different use case. My proposal is that the way to think about this is through multi-layers of ML and multi-layers of application. So back to that video example that I was giving you earlier, what we are proposing for these folks is not to like rip and replace the models they have on their back end, not at all, but instead be thoughtful about what you use it. So imagine on or next to every one of those cameras, you run a very, very lightweight model. And all it does is do object detection for a car or a human being. That's it. Then from that, you get enough information to clip and send the clip off to your much more sophisticated model on the back end. Just by doing that, they are now able to do exactly what their initial scenario was. Be faster with emergency response, for slips and falls, for car accidents, for a human being where a human being shouldn't be at 2 o'clock in the morning. Like, just that enables their emergency responders to be much more resilient. Now we get to demo, and networking has been weird. So what I'm committing to you is this. Go, get this, grab this, call me up anytime, day or night. If I cannot, within minutes, demonstrate to you and your team that this very demo that I'm about to show you works, $250. As a gift card, unfortunately, I can't give away cash. But $250 as a gift card in your pocket. Take me up on this. I'm serious. But now here. Everyone got it? I'm not joking. Money. All right, let's get to the demo. Again, I apologize because networking has been no bueno. And we're not off to a good start here. Okay, let's get into our guy here. So this is a real live running demo, and we are going to zoom in so that everyone can see. And examples, Edge, WASM demo. Okay. All right, what I have running here is a sample number of machines out there in the world. This happens to be, so this is, forgive me that this is a CLI. We have a hosted UI. This is much prettier, but we're all nerds, and nerds like to see deep stuff. So what I have here is I have a Bacalhau network set up. And obviously this is way too zoomed in, but you can see there, I'm not lying when I say there are many, many, many machines set up connected to this, okay? Just to show you here, we're going to grep, and we're going to show you the number of nodes, and we're going to word count Each line, 301 nodes. Okay? Leave me so far? Good. All right. So the first thing we're going to do, so each one of these things is set up in an edge configuration, and I have them set up to simulate 3 different regions. US region, EU region, and Asia region. Okay? And the first thing we're going to do here is we're going to run a job on 100 nodes in the US only region. Okay? I'm going to start it now because it takes just a second to get the first one going. But what am I doing here? So just to show you what this is, who uses Kubernetes here? Anyone? All right. Well, not very many. But I'll walk you through this. This looks very, very similar to what a Kubernetes looks like. If you already know Kubernetes, or your team knows Kubernetes, you're going to be able to get this in 1 second. If you don't know Kubernetes, we also have web-based ways to do what you're seeing here. But the point is that it's very, very straightforward. So all this does is it spins up a certain number of jobs. It's got these targets. So it's going to target anything with the label edge. It's also going to target anything with the label United States. And it's going to run a WASM job. This WASM job is a very, very, very boring machine learning thing, which spits out a random emoji. That's all it does. Okay? It's very dumb, but I'm just trying to show you that we could even run what machine learning. And you can see here it takes a little bit of input. Here's the emoji and here's the color that it's going to show. That's it. That's the entire job description, right? My entire job is running there. And now, when I go over here, all right, we have deployed, and we're off to the races. Good. Okay, so you can see here, this is live, and every 1 second or so, each job is notifying, hey, you know what? I updated my emoji here with my new ML, and I ran, right? Pretty straightforward. All right, well, like I said, I just ran one. Let's do some more. Here, we're going to go, and we're going to deploy one to EU, and we're going to deploy one to Asia. And when I go over here, we should see in just a few seconds. What's going on right now is it's handing that job to the back end. The back end is now talking to every node in the network, and each node in the network is saying, oh, wait, I'm a fit for this. I say EU. I say I'm Asia. So therefore, off I go, right? And that's what you see happening here. Make sense so far? Okay. And again, the only thing that changed from these various jobs, I happen to use the same backend. But what I did was I targeted, instead of targeting the US, I targeted Asia. And here with WASM, for Asia, I made it green instead of red because I wanted to, make it visible. Okay? So far, so good. All right. Now we're going to go, and let's say we want to update our job. So I'm going to update the jobs in the US. And again, this is the kind of thing where it's we're so easy to forget. Oh, wait a second, I deployed this. Is it working? Is it whatever? The system handles it for you, right? So it's going to go, I'm going to deploy this again, and I'm going to talk to you about what's going on here while it happens. It's now going out to every node on the network. It's finding anyone who is connected and says, hey, what's your job? What's available out there? And it's saying, oh, you were running this job. I now want to update you and run this other job here. And instead of running with a red border, I want you to run with a purple border. That's it. But it's going to do it just for the US. Make sense? So again, this isn't hard. It's not complicated here, but it's something where other platforms don't do this. Because they weren't built for it. Not because they're bad, just because they're not built for it. They're built to assume that it has constant connectivity to all these nodes. What do I mean by constant connectivity? Well, let's say, for the sake of argument, that I decide to pause an entire block of, connect. Let's say I decide to pause an entire block of nodes. What happens now, right? If you're in the Kubernetes world, or many other orchestrator worlds, it freaks out. It's what the hell is going on? These nodes are dead. Should I reschedule? Should I spin up new nodes? So on and so forth. And even worse, if I say, hey, you know what? I want to deploy a new set of jobs to those nodes, right? That's where other orchestrators get very angry, right? They're like, I don't have anything. I'm going to cancel this job immediately. Here, what you should be looking for is yellow color, right? So, no yellow, okay? As expected, because all those nodes are stopped, right? And now, if I say I'm going to reconnect them, okay? Those nodes come back up. And what we will see is, as those nodes come back up and notify the orchestrator, hey, you know what? I am now reconnected. Do you have any jobs for me? The orchestrator says, wait a second. You are a fit for these things that I wanted to place in the first place, and I'm going to swap them out. Make sense? Again, it's not terribly complicated. It's just there hasn't been a platform to date that thinks about this in a global, disconnected way. And especially when it comes to rolling out machine learning models and moving data around, this is critical. This is what's going to unlock the next generation of things, because you will be able to treat your entire infrastructure as a global solution instead of something as a one-off. Make sense? Okay, that's the demo. Again, I stress, I am happy to pay you $250. Come, collect the money. If I can't do it. So, in the machine learning world, what my proposal is that by running these jobs next to where your users are, you get much more efficient processing, right? It turns out that 100 machines with a 4-year-old GPU will perform way, 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 way better than a single or 5 machines with 16 GPUs each running in a single data center. That's not because those things aren't super performant. It's because of contention and noisy neighbors and all that mess, right? If you have a single node with a single GPU on it running next to your users, you're going to get so many advantages. On top of that, right, this becomes part of your GitOps for models, right? This is a declarative rollout. You heard earlier today Brian and Michael on stage talking about, hey, if it's not declarative, it ain't much. And that's what we help provide, right? What you saw here was declarative rollout, taking your jobs, being able to hand it to the network and saying, hey, network, you figure it out when something joins, when it doesn't. And then finally, audit trail, right? Every one of these jobs that you see here has a unique hash, unique identifier, and is ready to go, right? Which is so critical. It's so easy to say, you know what, I'm just going to roll this thing out, don't worry about it. And then a day, a week, a month later, your auditors are in, your SREs are in. Hey, which model was this that generated this data? It's so easy to forget that. Even if you have a model registry, it's still so easy to forget that because you didn't have an inference awareness about what job was running where. So I think I talked about most of this stuff, but like we have examples, full calculators showing how to save, 90+% on processing costs, 93% on bandwidth costs, all these kind of things. These are real numbers from real calculations, and we can show you how. This was an actual calculator we put together for someone, 87% lower across the entire stack. 258,000 proposed by a single hyperscaler becomes 34,000. We have a bunch of examples already that people are using us for. The US Navy is using us on UUVs, unmanned underwater vehicles, to do anomaly detection and things of that kind on sensor data and so on. There's a solar field in Southwest Australia, thousands of grids all over. Each grid comes with an inverter. Each inverter is generating data on a per second basis. These are connected over 4G if you're lucky. They're moving way too much data, and they need to have data in a very quick way. But they only need 10-minute windows, right? Because that's enough. If a cloud passes over a thing that's going to be too noisy. So if they're able to do aggregation before they move the data, that is a huge benefit for them. And we're helping them do that. And then City of Las Vegas, I mentioned earlier, using us in proof of concept to do video processing at the edge or near the edge. They actually have a number of these boxes all over the city for like little mini data centers spread all over the city, and we're helping them like organize them and move their data into that location. So, in summary, lots of customer benefits by moving your machine learning models near to where your people are. I'm not asking you to come up with new models. I'm not asking you to change your infrastructure. I'm not asking you to change languages. I'm not asking you to change your back end. I'm not asking you to adopt a new SDK. We can help with all of that stuff. My proposal is that the more that you can think about your infrastructure as a universal, holistic whole, the more that you can think about like detaching where something is executed from the orchestrator using an intelligent path, we can help. And that's what our open source platform does, and then of course our commercial company as well. And with that, I have a few minutes for questions. Thank you. Any questions? Yeah.
What kind of hardware do you support?
Anything Go compiles to. So ARM v7, ARM v8, Intel x86, GPUs, I don't know, you take it, you name it. Go supports a lot of stuff, including TinyGo, actually. This here you see is TinyGo. We also, by the way, have a Docker and Docker for our agent. So there's two layers here. Layer one is our agent, which is the thing that coordinates all this stuff and understands how to like connect and disconnect and this, that, and the other. The second thing is the executor, okay? And the executor is native to whatever you have. So what you'll do is you'll run our agent, but our agent does very little, right? Apart from like handling all this distributed consensus, its job is to call whatever executor you have told it about, which could be Docker or Wasm or whatever. So you could run our agent in a container on the device and then have that agent call a native compiled whatever binary on that node, and then that runs as well. Does that make sense? Other questions? Yes.
Distributed consensus, how does that work?
So that's kind of our secret sauce. I mean, it's not secret, it's all open source, so you can go check it out yourself. The orchestrator has an awareness of all nodes in the network, okay? Every node has an awareness of what it is doing, what jobs it's running, what containers it's running, what jobs it's been scheduled to, so on and so forth. When things, by and large, the orchestrator maintains the order book, and it just is fine and everything is good. However, if a node misses a heartbeat, then we assume some form of divergence. And when the node reconnects, that's where you have to get to distributed consensus. So it's not everybody knows about everything. It is we can resolve this much better. Kubernetes, I love her. I'm not speaking ill of her, but like Kubernetes does not do this. When the node reconnects, it assumes everything is dead and it flattens it, which is not bad. It's just how it was designed. What that means is that if you're doing things in a very, very high throughput job way, you will want to use Kubernetes or Nomad or something like that because it can schedule things without doing some check-in with the node. We cannot. We schedule, we say, oh, you're reconnected now. Before I schedule you into a job, let me resolve what happened while we were disconnected. Make sense? Yep. Any other questions? Yeah.
Your WASM example, what WASM components?
I don't know. Oh, the question was what WASI components. Oh shit, I didn't answer the earlier one. He asked about distributed consensus earlier. I hope it was clear. What WASI components? I will be honest, I'm not sure. I do not remember. I apologize. It's really lightweight. It was compiled with TinyGo, by the way. So so I actually don't know. I don't know if TinyGo injects stuff along the way, but there you go. Yes, other questions? Anything? I have 5 minutes. You can ask anything you like. Yeah.
Let's say you have a device on the edge that has some hardware capability different than other devices on the edge. And you want to deploy a different model that's quantized for the set of edge devices and not these edge devices.
Yeah.
Is that possible?
Absolutely. That's what you see here is exactly that. What you would do is, the easiest way to do it is just use the labeling, the native labeling. So when you start a node, you get a bunch of labels. Okay? I mean, I think we support, I might be mistaken, but I think we support unlimited labels. If not, it's 255 or some set amount, right? And so you would simply say, hey, here's my architecture. We also give you for free some labels, like right out of the box. So this gives you and you can decide what labels you'd like to attach to it. This gives you that it's AMD 64 and Linux operating system, just based on the command it starts. And so again, you can add whatever labels you'd like, and that would be the easiest way to do it. We have had requests to integrate something with a little bit more native querying. So using something like OS Query or something like that, allow people to issue queries to the nodes as a whole that enable you to go there. And then you don't have to do any labeling, but we haven't seen enough demand for that. And because you can already achieve it with just labeling when you start, that's enough for most people. Of course. What other questions? Anyone have any big data or ML challenges that you'd like to talk about? I'm always fascinated about that. Datadog bill's too big, Splunk bill's too big, Snowflake not responding fast enough, Cosmos not responding fast enough. Sorry, we have some Azure folks in the front. All right, well, I'm here, and thank you so much for coming again.